Figures 19.10 and 19.11, TimeComparator.java and sort3.java. In this example, we're going to use a class called Time2 from an earlier chapter in our book, Java How to Program. And we're going to create several objects of this class Time2 and then sort them into time order. So let's first review class Time2, which maintains the time in 24-hour clock format using three integer variables, hour, minute, and second. It provides a bunch of different constructors to enable us to initialize objects of class Time2. The default constructor will set the time to midnight. The constructor with one argument will set the hour and then set the minutes and seconds to 0. The two-argument constructor will set the hour and minute and then the seconds to 0. The three-argument constructor will use whatever three values you receive, and each of these other constructors is calling this constructor. And then finally, the constructor that receives a time2 will simply copy that time2 object's values into this new object that we are creating. Separately, we also provide a setTime method and individual setHour, setMinute, and setSecond methods, and also getHour, getMinute, and getSecond methods. And then finally, we have a toUniversalString method to give you a string format for a 24-hour clock, and a toString method that will give you a string format for a 12-hour clock. Now, our sort3 example is going to create several objects of our class Time2 and store them in an array list. So let's take a look first at the main method, where we create an object of our sort3 class and then we call its printElements method. Here's printElements. Inside of printElements, we create an array list of type time2. So we're actually going to store references to time2 objects in this array list, and we assign that to a list variable for type list of time2. And then we start adding items to the list, and we create for each item a new time2 object, and we purposely place the objects into the list in an order that is not sorted. So we've got 6 a.m. with 24 minutes and 34 seconds, we've got 6 p.m. with 14 minutes and 58 seconds, 6 a.m. with 5 minutes and 34 seconds, 12 p.m. with 14 minutes and 58 seconds, and then 6 a.m. with 24 minutes, and 22 seconds. So we create 5 different time2 objects, and as we create each one, we place it immediately into our list. Then we output the list in string representation to show you each of the time2 objects in their default string representation, which will be the 12-hour clock format in the exact order that they were listed in this set of statements at lines 13 through 17. Now, the key piece in this example is the call to collections.sort, where we give it our list of objects that were not defined to be comparable in the first place, and then we give it an object of our own class called TimeComparator, which I'll look at with you in just a moment. This implements the comparator interface and enables us to figure out the sorting order of all of these time2 objects. And then finally, after we've sorted those objects, we will display the list again. Now, before I look at the comparator, I just want to show you that we were able to sort the objects. So if you take a look at the output window here, you can see the strings representing all of the times with AM and PM as necessary for the 12-hour clock format, and you can see that they clearly are not in sorted order. And then you can take a look at the sorted list of times, and you can see that we have 6:05 and 34 seconds in the morning, 6:24 and 22 seconds in the morning, 6:22, 24 and 34 seconds in the morning, 12 noon, 12:14 and 58 seconds in the afternoon, and then 6:14 and 58 seconds in the evening. So we were able to sort the objects. The question is, how did we sort those objects? And we did so with an object of our class called TimeComparator. So let's take a look at that class. You'll notice that we've included, or imported rather, the comparator interface from the java.util package, and our class TimeComparator says that it implements comparator of type time2, which is an interface that is now specialized to type time2 in which we are going to be forced to implement a compare method that receives two time2 objects by reference and then compares them. And this compare method is going to return a value indicating whether or not or not indicating whether or not, but indicating how to determine the sort order for the two objects. Now let's go to the actual util package in the online docset, and let's take a look at the comparator interface so that you can understand the purpose of its method. You'll see that actually there are two methods here, compare and equals. We're actually only overriding the compare method. The equals method is in fact inherited into our time2 objects and our time comparator objects as well, because any class that extends object automatically gets an equals method. In our case, we don't really care if the objects are equal. What we care about is if the objects are less than or greater than one another. So we've implemented the compare method. It receives two objects of the same type, and then it's going to return an integer value indicating the sort order. So again, we have to determine the sort order based on comparing the actual values. And the key thing that we're concerned with is whether the first object passed to the comparator is greater than or less than the second object. So in this case, really we care if it's greater than the second object. So what we do is we receive into our compare method the time2 objects, and then we create an integer called our compare, and we subtract from time1.getHour the value of time2.getHour. Now if time1 is greater than time2, then its hour value will be greater than time2's hour value, and the result of this subtraction will be a positive number that will indicate that time1 is greater than time2. So if our compare is not equal to 0, we return the value of our compare. And if our compare is a positive number being returned, that would mean time1 is greater than time2. And if the value is negative, that would mean that time1 is less than time2. And that in turn will help the sort method determine the sort order for the objects. In particular, if time1 is greater than time2, that would mean that the objects need to be exchanged in the underlying data structure because they're not in the correct order. Now separately, if we get past this because the hours are equal, the result would be 0 in that case. Then we'll create the minute compare value by subtracting time1 from time1's minute value time2's minute value. And again, if this is 0, that would mean that the minutes are equal, but if it's non-zero, that would help us determine that the first time object is greater or less than the second time object, and we would then return that value here at line 20. And finally, if the hours and the minutes are equal, then we will do a comparison for the seconds. We will subtract time1's value of second, time2's value of second from time1's value of second, and the value of that will then be returned to the caller so that we can determine the sort order of the time objects. So finally, we go back to our main application here, and when we do, this object contains that compare method. So what happens is the sort method picks out two values from the underlying list, passes them to the time comparator's compare method, and then uses the result of that method to determine the sorting order in this example. And then we print out the list representation once again to show you the sorted list. So this is an interesting example because it shows you that you can basically retrofit classes that were not intended to be compared originally so that you can indeed compare objects of those classes and use them with methods like sort for determining the sort order, or if we wanted to provide a properly implemented version of the equals method in our time comparator, we could even use that with binary search as well to determine if a particular time is in a list of time2 objects.
Looking to advance your career by acquiring new skills? Tired of expensive off-site training programs? Wish you could learn from the best instructors in the industry? Look no further than live lessons. Self-paced, personal video instruction by the world's leading technology publishers. Each live lesson comes with a DVD featuring 3 to 4 hours of instructor-led classroom training, sample program code that allows you to work along with your personal instructor, and an example-rich study guide. Live lessons allow you to watch the entire course from start to finish, or navigate directly to any of the individual lessons. You'll literally watch over the shoulder of your instructor as he shows you how to build state-of-the-art applications. Live lessons, the power of the world's leading technology experts at your fingertips. To learn more, visit mylivelessons.com today.